Hello, hi everyone. Welcome to the next video of this series. So in this video, I am going to discuss next chapter of the organic chemistry, which is haloalkanes and haloarenes. Very simple and easy chapter. If you know the concepts of general organic chemistry and reaction mechanism, then you can do most of the questions without knowing the reactions of haloalkanes and haloarenes. Even most of the reactions of haloalkanes and haloarenes, they are the part of the hydrocarbons. Okay, so I have discussed in the first video of the organic chemistry how hydrocarbons is the most important chapter, right? If you do hydrocarbons very well, then you can do maximum number of questions, right? So I am getting a request ki ma'am please make video on GOC, right? Ma'am please make video on reaction mechanism. So students, for your knowledge, I am taking some questions of GOC and reaction mechanism with respect to all chapters, or I am incorporating all these questions in all chapters. I have taken some questions in hydrocarbons. I am going to take some questions in haloalkanes and haloarenes. So in that way, I am going to discuss the concepts of GOC and the reaction mechanism with you. But idea is that if you are doing the organic chemistry, so just go through all the preparation, just go through all the reaction mechanism, just go through all the reactions, because the main issue in the organic chemistry is that you know the concept, you know the application part, but it is difficult to retain, it is difficult to memorize all these reactions. So my suggestion is that it's just you have to jot down the reactions, important reactions. If it is related to preparation, so just write it down. If reactions are related to the properties, then just write it down. So in that way you can master organic chemistry. Okay, so now we are going to move in a systematic manner, so let's do it. Haloalkanes and haloarenes. So let's start in the systematic manner. So first, how to use this video. You have to revise the short notes, and how to revise the organic chemistry notes I have already discussed in the hydrocarbons video. First, you have to revise GOC and reaction mechanism. That is the important part. We are going to apply the concepts of GOC and reaction mechanism in all chapters of organic chemistry. Then you have to revise your haloalkanes and haloarenes notes. ठीक है, हेलो alkanes and haloarenes notes. Okay, now important information, you have to write down the preparation reaction, you have to write down the chemical reaction. But when you write chemical reaction preparation and all, so you should know ki what kind of addition or what kind of substitution is there. Do we have SN1 substitution, do we have SN2 substitution in this reaction? Do we have E1 elimination, E2 elimination? Do we have syn addition, anti addition, right? So you should know all these things with respect to all chemical reactions, right? What are the temperature conditions, or we can say reaction conditions, that you need to mention when you write down the notes, when you write down your short notes, right? Reaction conditions. And then you can start doing the practice by doing some questions. Now this is the high time when you do PYQs, because this is not the time when you solve from the scratch. So just solve maximum number of PYQs so that you can get the idea what type of questions are coming in the exams. Right, now halogen derivatives. First I'm going to discuss weightage, syllabus, then syllabus in terms of mind maps, and then PYQs I will be discussing. If I talk about the weightage, so see, all organic chemistry questions, they are interrelated. So if I say ki only from this chapter, how many questions are going to come specifically from this chapter? So you can say one question at an average. Or this is the trend in chemistry ki basically one question is going to come from every chapter, right? So every chapter in chemistry is important. So you have to learn, you have to revise all chapters of chemistry. You cannot do ki like let me do this chapter and I'm not going to solve other chapter, I'm not going to read that chapter, because that is not as per my interest right? Because you will get questions somehow, right? So that is the important thing, you should revise all chapters of chemistry. Okay, so this is around 4%, we can say कि one question is going to come. Now if I talk about the mind map, so here we have haloalkanes, right? We have haloalkanes, and we have haloarenes. Okay, in haloalkanes we have Rx, and in haloarenes we have ARX, aryl halide or aromatic halide and all. Okay, so you should know what you should know. of this part, what you should know of this part, in haloalkanes you should know the preparation. ठीक है, तो preparation of haloalkanes and haloarenes, you should know the physical properties with respect to haloalkanes and haloarenes. If we talk about physical properties, so major properties, they are going to be melting point, boiling point, and solubility in water. They are going to be most important, right? Physical properties. Then chemical properties. Chemical properties for both haloalkanes and haloarenes. And last but not least, uses, and uses you have to do from NCRT itself, right? So this is going to be the mind map. There are lots of chemical reactions. It's just you have to write down everything. And when you are solving question, if you are the beginner and you don't know how to attempt question and what is the correct way to attempt the question, so just write down all the reactions with you, write down everything, SN1, SN2, E1, E2, syn addition, anti addition, right? So you should write everything and just open that reaction mechanism file or whatever, your notes, right? Or open that one and then start solving question so that you can relate it. Oh, this is the reaction and I have to apply this reaction in this question in that way, right? So this is the way. That is just for beginners, right? But if you know the concept very well, then you can start doing the practice. Okay, so I have divided this chapter into again some different types. So in the first type, I am going to take up some questions which are related to basics. And when I say basics, it means I am going to take questions which can be solved only from the concepts of general organic chemistry and reaction mechanism. So in the general organic chemistry, what happens, you should have idea about intermediates like carbocation, carbanion, carbon free radical, and their stability. So carbocation and carbon free radical, they are electron deficient species. And they are stabilized by electron releasing group. And how do we say that which group is electron releasing group? So the group in which atom has lone pair, or we can say the atom has negative charge. It's not, X is not the halogen, right? It's an atom. I'm saying X atom, we have X atom. So lone pair and negative charge can be present, or we can say atom should be less electronegative. So these are the three conditions which you need to check, right, in order to differentiate whether this compound is electron releasing or electron withdrawing. If we have carbon ion, so carbon ion is electron rich species, or due to the negative charge, so repulsion is more. So in order to stabilize carbon ion, electron withdrawing group should be attached to carbon ion. If we have more electron withdrawing group, then carbon ion is stabilized. Now how to check for carbon ion? So we should be X, that is double bond Y, X triple bond Y, or X positive. If you see these type of groups, it means they are going to be the electron withdrawing group. Okay, now in reaction mechanism, we have substitution reaction, elimination reaction, and addition reaction. These are the three major reactions, right? So substitution may we have nucleophilic substitution and electrophilic substitution. Then in addition, we have electrophilic addition and nucleophilic addition. Okay, and then we have elimination reactions. So in elimination reaction, we have E1, E2, and E1 CP. So these are the most important reactions that you know. What are the conditions for SN1? What are the conditions for SN2? Like someone asked, ma'am, is SN1 faster or SN2 faster? Obviously, SN2 is faster than SN1. But by the knowledge of this, we cannot identify by in this reaction which reaction mechanism you have to follow. So there are certain reaction conditions which should be there, or which will tell us ki this reaction proceeds via SN1 or SN2 or E1 or E2, right? So let's discuss type 1 questions. So let's discuss that. Question number 1 says assertion. We have assertion reason type question. So first says hydrolysis of an alkyl chloride is a slow reaction. So just try to get the information. Hydrolysis of an alkyl chloride. Hydrolysis means if we have alkyl chloride, suppose RCl. Hydrolysis means we can say we are going to react this with aqueous NaOH, or we can say H2O in the presence of OH minus, right? We can say this thing. So what happens? It says hydrolysis of alkyl chloride is a slow reaction, but in the presence of NaI, the rate of hydrolysis increases. In the presence of NaI, the rate of hydrolysis increases. So see, RCl. So what happens after hydrolysis? OH minus attacks on this R group. Why? Because chlorine is more electronegative, so we write delta negative, this is R positive, and Cl leaves. So we get ROH. ठीक है. अब it says कि but in the presence of NaI. So if you add NaI, so what happens? We have Na plus and I minus. ठीक है. So if you add NaI, so the rate of hydrolysis increases. Why? Because see, we have RCl, and if you add NaI, right? So what happens? We get Ri and NaCl. So why? Because I minus is a good nucleophile. It is a good nucleophile. Why it is a good nucleophile? Because this is less electronegative. So if this is less electronegative, so it has more tendency to give the lone pair easily, right? So it means what happens? We get Ri. Up now, if we have Ri and we say ki OH minus wants to attack on this R position and I should leave, so we get ROH, right? ROH. So point is that I minus is a good leaving group also. It's a good leaving group also. Why it is a good leaving group? So see, we have carbon and iodine bond. So iodine is bigger in size while carbon is small in size, right? So bond dissociation energy of Ci is very low, So I minus can leave, right? I minus can leave easily. So rate of hydrolysis also increases. Understood? So rate of hydrolysis also increases. So we can say this is true. Now, I minus is a good nucleophile as well as a good leaving group. True. That is why we can say assertion is true, reason is true, and reason is the correct explanation of the assertion. I hope I am clear. Okay. Now let's do next question. Number of moles of AgCl formed in the following reaction is AgCl. You have to form AgCl. So see, in the substrate, we have Cl, right, which is bonded to carbon, right, and reagent is AgNO3. So we know that if we have Cl minus, so Cl minus on reaction with Ag plus forms precipitate of AgCl, right or wrong? So point is that if we remove Cl minus, then carbocation is formed, right? Carbocation is formed. So it means we have to check those positions where carbocation is more stable. And we know that carbocation is stabilized by electron releasing group. Or the group which shows plus I, plus R, plus M and plus H. All plus H electronic effects. So they stabilize carbocation. So now just try to see. If you see this Cl, if I remove this Cl, so we have carbocation on this carbon, right? We have carbocation on this carbon. Now this carbocation is bonded to 3 carbons. So here we form, this is going to be the 3-degree carbocation, right? This is going to be 3-degree carbocation. Now 3-degree carbocation is stable. It is stable because in 3-degree carbocation we have 3 electron releasing groups. See, CH3, suppose this CH3. So 3 electron releasing group. Here we have plus H. Why plus H? This is alpha hydrogen, this is alpha hydrogen, this is alpha hydrogen. So we have 9 alpha hydrogen. So we get more hyperconjugated structure, and if we have more hyperconjugated structure, then more is going to be the stability. Now let's see this one. If I remove this one, so we get carbocation on this, which is 2 degree, because now it is bonded to 2 carbon. But if you see this properly, here we have resonance, right? In the benzene we have resonance, no? See, so we have resonance, and this is called benzylic carbocation, right? Benzylic carbocation, which is resonance stabilized, which is resonance stabilized. So here we can form easily. Now let's check for next one. Let's check for next one. What about this? Nuke. If Cl leaves, so we have positive charge on the benzene ring. Is it stable? No, it is not stable. Okay. So carbocation cannot be formed over here. A point is, if we remove Cl over here, so we have positive charge over here, which is positive, and this. Is it stable? No. Positive charge cannot be formed on double bond, right? If we do not have any other reaction. So the point is that only two are the possible places from where Cl minus can remove. So we get x mole of AgCl. X mole of AgCl, na? So the value of x is equal to 2 mole. So answer is going to be 2. Answer is going to be 2. Clear? Now moving on to the next question. Decreasing order towards SN1 reaction. So if we talk about the SN1 reaction, bete, so SN1 reaction proceeds via two steps, right? So in the first step, what happened? Carbocation formed. In the first step, carbocation is formed. Carbocation is formed, and in the second step, nucleophile attacks. Okay, so suppose we have C positive, CH3, CH3, and this is CH3. Or we can write, suppose it is Cl. So in the first step, what happens? Cl leaves. It leaves. So we get CH3, C, CH3, CH3 positive, and Cl minus leaves. Now what happens? We have any nucleophile. I am saying nucleophile as this, Nu, nucleophile. So it can attack on this carbon, and we get this. Okay? So this is the mechanism which we follow in SN1 pathway. Point is that more stable carbocation forms more, or we can say forms major product. So question says decreasing order of SN1 reaction. So basically we have to check the stability of carbocation. Check the stability of carbocation in this. So this is a question related to GOC, na? It means we have to check the stability of intermediate. So how to do this? See, if you remove Cl over here, so we get positive charge on this carbon. If you remove Cl over here, so we get positive charge on this carbon. If you remove Cl over here, so we get positive charge on this carbon. And if you remove Cl over here, so we get positive charge from this carbon. Okay. Now, see, we have Cl. So Cl, it shows minus I effect. So this is electron withdrawing group. OMe. So oxygen has lone pair now, so it gives electron to the system. So this is electron releasing group, and here we have plus M effect. If we talk about NO2, so NO2 is the electron withdrawing group because it can take electron from the system. It shows minus M. So carbocation is stabilized in the presence of electron releasing group, not in the presence of electron withdrawing group. ठीक है बेटे? So here we have plus M, in the first case minus M, in the second case plus M, in the third case we have minus I, and D में no group. So the point is that electron releasing group stabilize the carbocation more, so B is going to be the more stable, right? So if B is going to be the most stable one, so in that one SN1 reaction proceeds easily. So from this we can take this B. right? Up now after B, we have D, because D may we have no group. So D. Then C, why C? Because minus. Minus means partial transfer. Ki suppose Cl is more electronegative. So what happens? Now the bond pair of electron of this bond, they are more closer to Cl side. Not, they are not closer to carbon side. So it's not taking the electrons completely. But NO2 is taking the electrons completely, right? NO2 part, it is taking the electrons completely. Transfer of electron happens. So here A is going to be the least. So option 3 is going to be the correct answer. Now moving on to the next question. Identify the incorrect option from the following. So here you should know the role of reagent. Reagent. So see, if we have aqueous KOH, it will do SN1 or SN2. SN1 if we have 3 degree substrate or 2 degree substrate, and SN2 if we have 1 degree and 2 degree substrate. If we have alcoholic KOH, then it will do elimination either E1 or E2, but E2 is preferable, ठीक है, elimination, but that also depends on the degree of substrate. Even if we have 3 degree substrate and 2 degree, and E2 if we have 1 degree and 2 degree, ठीक है. If we see this CH3, COCl and anhydrous AlCl3, so they are the part of Friedel-Crafts acylation. So in Friedel-Crafts acylation, we have the generation of CH3, C double bond O positive, and we have electrophilic aromatic substitution. Okay. Now here NaOH and Cl. So this is the nucleophilic substitution. Now we know that nucleophilic substitution is difficult on benzene ring, right? Benzene ring. So for that, temperature should be more or pressure should be more. So if you see the reaction conditions properly, so here temperature is 623 Kelvin and pressure is 300 atm. Understood or not? So now we have to proceed in that way. So see clearly, this is 1 degree, because this functional group is bonded to one carbon, so this is 1 degree. 1 degree hai, so here we have SN2, so aqueous KOH you can put OH. Very good, you can get this one. ठीक है बेटे. Now second, this functional group is bonded to one carbon, matlab 1 degree carbon, so this is also 1 degree, but we have alcoholic KOH. So if we have alcoholic KOH, so we are going to do elimination, and in elimination product is going to be alkene, not alcohol. So here we have alcohol, to answer this is wrong. This is going to be incorrect option. If we talk about this one, so electrophilic aromatic substitution, so say we can get ortho and para directing COCH3. It can happen. Now Cl is replaced with OH. That is the SN2, right? That is the SN2. Now in the second one, we have this one, right? We have this one, and we have alcoholic KOH. So how to do this? So what happens? First Br minus leaves. So we get carbocation formation over here. Then we do methyl shift, because 1 degree carbocation nahi hai na stable. So we have to check whether we can do rearrangement or not. So let's do methyl shift. So we have positive charge over here. Okay, positive charge over here. So now we have beta hydrogen over here, beta, but these are same. And then we have beta 2 hydrogen over here. So in order to get ZZ product, we have to remove hydrogen, which is beta 2. Just see here we have 3 hydrogen. Here we have 3 hydrogen because this is a methyl group, and here we have 2 hydrogen. So OH minus alcoholic KOH, OH minus takes this hydrogen and electron of this bond shifts over here. So we get this product as the answer. Clear? That's it. So option 2 is going to be the correct answer. This is the incorrect one. Okay. Now moving on to the next question. The next question is also based on the reaction mechanism. So let's read it. For the reaction RCH2Br plus I minus in acetone gives RCH2I and Br minus. So the correct statement is. So the point is that let's find out the degree of substrate. This is the first point, right? Let's find out the degree of substrate. So we have R CH2 Br. So this functional group is bonded to 1 degree carbon. So 1 degree carbon hai, so it means we can do SN2. I minus, so I minus is going to be the nucleophile. Okay. Now we have acetone. Acetone is CH3, C double bond O CH3. So this is the polar aprotic solvent. Polar aprotic solvent. So what are polar aprotic solvent? Where hydrogen is bonded to less electronegative atom. So here hydrogen is bonded to carbon, which is less electronegative. So this is polar aprotic solvent, and polar aprotic solvent favors SN2. Okay. So we get what? Nucleophilic substitution. In place of bromine, we get iodine, and Br minus leaves. Okay, fine. So correct statement you have to identify. The first statement says Br minus can act as a competing nucleophile. No. Why it is not true? Because in SN2 we have the formation of transition state. We have the formation of what? Transition state. So if we say we have C, this is R, this is H, this is H, and here Br and here I. So it means carbon I, this is the new bond which will form, right? New bond which will form, and this is the dissociation of old bond. This is the dissociation of old bond, right? Old bond. Now what happens? Slowly new bond is going to form and old bond is going to dissociate. So abhi right now at this position Br minus cannot act as nucleophile, है ना? Cannot act as nucleophile. Why? Because it is in association. It is in association. It is in association. And we know that I minus is a better nucleophile as well as better leaving group. So what happens after some time? We have Cr. Here we write I. Here H plus Br minus. Clear? Fine. So Br minus cannot act as nucleophile. Second, the reaction can occur in acetic acid. Now, if we see acetic acid is this. So this is the polar protic solvent. Polar protic solvent. What is polar protic solvent? Where hydrogen is bonded to more electronegative atom. Hydrogen is bonded to more electronegative atom. And polar aprotic solvent favors SN1 reaction. But it favors SN1, it can favor SN1 if we have some kind of rearrangement possible. It means if somehow we can do rearrangement and get a more stable carbocation, then it is possible. Okay, so from here, if we have rearrangement, then that can happen, otherwise no. So in this situation, we cannot have more stable carbocation anyhow. So this is no, complete no. Next, the transition state formed in the above reaction is less polar than the localized anion. Yes, this is true. This is true. Localized anion means, as for example, we have I minus, yeah, Br minus and all. So if you see, if I check the dipole moment, so here dipole is towards Br side and here dipole is towards iodine side. Understood? So obviously it is going to be less polar. It is going to be less polar because now two dipoles, they are in opposite direction. So it makes the transition state less polar, which is true. Answer should be 3. Now let's read the fourth. The solvent used in the reaction solvates the ions formed in rate determining step. So acetone, polar aprotic solvent, it solvates cations only. Cations only. It does not solvate anion. Okay. So that's the reason ki fourth one is also the incorrect one. In SN1 we have polar protic solvent. So polar protic solvent solvates both cations and anions, but polar aprotic solvent solvates only cations. Okay. Now moving on to the next question. Choose the halogen which is most reactive towards SN1. It means SN1 you have to check where SN1 can be faster. So for SN1 we have to check the stability of carbocation. Right, we have to check the stability of carbocation. So let's do it. So if we see first one, So if I remove Br, so we get positive over here, which is 2 degree carbocation because it is bonded to 2 carbon. Now if I remove this Br, so we get this. This is also 2 degree, but this blue one is going to be 2 degree benzylic. So 2 degree benzylic means like this, right? Benzylic, because it is resonance stabilized, so this is going to be more stable. So here A is going to be fast. So in option A, BRA shows faster reaction. Now if we look for the options, so we have only 2, 3 and 4. Now how to solve this question in no time? If you see how to solve the question in no time, so we have to check the difference. So see, B ka to in both the cases we have iodine AA, so there is no need to check. Now D bhi it's same. Now we have to look for C. If we identify C correctly, we can mark the correct answer, right? We can mark the correct answer. So let's see C. So C may, if I remove Br from here, so positive charge over here, which is 3 degree. And if I remove Br over here, so we will have positive charge over here, which is bridgehead carbocation. Which is bridgehead carbocation. Highly unstable. Highly unstable. So in C1, which one is more stable? Where we can say ki SN1 can happen? B position. So on the basis of that, we can say ki third option is going to be the correct answer. Third option is going to be the correct answer. Now we can also check, because we are learning, we are in a learning process, so we can also check. So see, and also check other options. So see, if I remove this, so we get positive, which is 1 degree. If I remove this, so we get positive over here, which is 3 degree. So obviously 3 degree is going to be more stable na carbocation. So here BRA. Now check over here. If I remove this, so we have positive charge over here, which is allylic, because resonance stabilized. And if I remove IB, so we have positive charge over here, which is 1 degree. So here IA more. ठीक है, मतलब IA यानी iodine, which is at A position. So if I remove iodine from here, so we can have more SN1 reaction, right? Or it is more reactive towards SN1. So on the basis of that, we can mark third option, right? So that is going to be the third option. A, BRA, BIA, C, BRB, and D, BRA. Okay, clear? That's it. Now moving on to the next question. So next question says the isomeric butyrated bromide with molecular formula C4H8DBr having 2 chiral carbon atoms. Now, 2 chiral carbon atoms means we should be having 2 carbons which are bonded to different groups, So how to check these kind of answer? You can easily mark the correct answer from the options given below. Right. So for example, if I say 2 bromo 1 deuterobutane, if I have A, so 2 bromo 1 deuterobutane, so butane, this 2 bromo and 1 we have deuterium. Okay, so we should be having how many chiral centers? So here we have H, here we have H, here we have H, 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 H. So if you see, we have only one chiral center. We have one chiral center because this yellow carbon, it is bonded to 4 different groups, right? It is bonded to 4 different groups. Okay. So this is the incorrect answer, incorrect option. Now second, 2 bromo 1 deutero 2 methyl propane. So let's check this one. So propane, 2 bromo 1 deutero and 2 methyl propane. So CH2 and here CH2. So if you see, or we can say here we write CH3. ठीक है बेटे? So if you see over here, so again we have only one chiral center na, only one chiral center. So again this is incorrect because we have one chiral center. Now check for the third option. 2 bromo 3 deuterobutane. 1, 2, 3, 4. 2 bromo and 3 deutero. 2 bromo and 3 deuterobutane. So this is CH3. Here we write CH3. Here we write H. Here we write H. Now we have 2 chiral centers. See, for this carbon, we have different groups, hydrogen, methyl and bromine, and this complete group. That is going to be the different group, right? Up now, if I write the same compound, CH3, CHBr, and then CHDCH3. So for this one, we have four different groups. Okay, so we have two chiral centers. So two chiral centers, they are present over here. So two chiral centers are present. So answer is going to be C. Now we can also check for the D one. Why D is incorrect? So D, if we check for D, 2 bromo 2 deuterobutane. 1, 2, 3, 4. 2 bromo 2 deuterobutane. So again we have only one chiral center beta. है ना, only one chiral center. So that's why answer 2 is going to be, C is going to be the correct answer. Clear? Now moving on to the next question. Again question says the correct order of reactivity of following haloarenes towards nucleophilic substitution with aqueous NaOH. So see, we know that nucleophilic substitution is difficult on benzene ring, right? Nucleophilic substitution is difficult on benzene ring. But if we want to do, only possible if you increase temperature, increase pressure and attach electron withdrawing group. Electron withdrawing group withdraws electron from the system, makes the ring electrophilic, due to which nucleophile can attack. Electron withdrawing group withdraws electron, makes the ring electrophilic, and then we can say nucleophile can attack. Okay, so it just we have to find out there are no temperature condition, pressure condition is not there. It means we have to look for electron withdrawing. So NO2, one electron withdrawing group. OMe, oh, electron releasing. Here 3 NO2 group, 3 electron withdrawing group, 3 NO2 group, 3 electron withdrawing group. And if you check A, so no electron withdrawing group. So correct order of reactivity of following. So the first D is going to react faster. Then we have B, then we have A, and then we have C. Electron releasing group में it is going to be least. ठीक है? So if you see the answer, so option number D is going to be the correct answer. I hope I am clear. Okay. Now moving on to the next question. Rate of SN2 will be negligible in SN2, SN1, whatever, right? So negligible in, it means you have to check the stability of carbocation only, right? Or we can say ki where nucleophile can attack easily, right? Nucleophile can attack easily. So if you see, we have a 6-membered ring. So 6-membered ring है तो steric hindrance we cannot decide, right? The steric hindrance wala thing. But you can check over here. You see, you just check the carbocation stability. So if you check the carbocation stability, you can do the question. So if you remove Br, so we have positive charge over here. If you remove Br, you have positive charge over here. If you remove Br, you have positive charge on bridgehead position. Bridgehead position, right? And if you remove Br, so you have positive charge over here. ठीक है, तो अब now if you see over here we have two double bonds ना, sp2 hybrid carbon. तो sp2 hybrid यानी trigonal planar, and if we say trigonal planar, suppose trigonal planar, so steric hindrance is going to be less because angle is going to be 120 degree. Understood? Are you getting this point? So if you see, the least steric hindrance is going to be in B. ठीक है, then we have in D, then we have in A, and then C, because C में तो we have bridgehead. C में तो we have bridgehead. Understood or not? So in B we have 2 pi bonds, in D we have 1 pi bond and in no pi bond. So it means अगर pi bond है, sp2 है, so trigonal planar है, angle is more. If angle is more, so less steric hindrance is going to be there. Understood? So answer is B, D, A, C. Okay, clear? That's it. Now moving on to the next question. Identify the correct order of reactivity for the following pairs towards the respective mechanism. SN2. See, if you remove this, so we get, so this is 3 degree na, and this is 1 degree. So obviously SN2 is faster than 1, right? So this is true. Correct. Now, if you remove Br over here, positive over here. If you remove Br over here, positive over here. So we have benzylic. So benzylic carbocation is more stabilized due to resonance. Due to resonance. So this is also correct. Now let's check for C1. Let's check for C1. Electrophilic substitution. Electrophilic. So for electrophilic, ring should be nucleophilic. है ना? For electrophilic substitution, ring should be nucleophilic. Nucleophilic. So here we have one electron withdrawing group which makes the ring electrophilic. Makes the ring electrophilic. So nucleophilic electrophilic substitution is slower. So it means third one is also correct. Now answer is going to be the fourth one, right? अच्छा नहीं, क्वेश्चन है पूरा आइडेंटिफाई द करेक्ट. तो नाउ फोर्थ न्यूक्लियोफिलिक सब्स्टिट्यूशन. अब नाउ न्यूक्लियोफिलिक सब्स्टिट्यूशन सही बात है here because one electron withdrawing group makes the ring electrophilic, so nucleophile can easily attack. So all are correct, है ना? All are correct. So if all are correct, so we see answer is going to be option number 2, A, B, C and D. Clear? That's it. Now let's move on to the next question. The next question says assertion is there. SN2 reaction of C6H5CH2Br occurs more easily than the SN2 reaction of CH3CH2Br. It says कि if we have C6H5CH2Br, right, it occurs more easily than CH3CH2Br. Is it true? Yes, it is true. Why it is true? Now try to understand over here. See, we have C6H5. Okay. So here we have CH. This is Br. And here we are going to form bond with the nucleophile. Okay. So this transition state, we have basically 5 bonds of 1, 2, 3, 4, 5. So the geometry is similar to trigonal bipyramidal. Bipyramidal. Okay. And we have C, Br. Here we write nucleophile. Here we write hydrogen, hydrogen. Here we write C, H, H, and then CH3. If you see this, there is more steric hindrance, right? There is more steric hindrance. Why? Because this carbon, it is sp2, sp3, and this carbon is sp2. So if sp2 is more, so it means theta is more, 120 degree, na, almost equal to 120 degree. So if theta is more, so repulsion is less. Repulsion is less, or we can say steric hindrance is less. Steric hindrance is less. Or the next reason is that we have partially unhybridized p orbital. Yeah, partially bonded unhybridized p orbital because sp3d hai na. But again we are going to convert this sp3. We are going to convert this into sp3 na. So we say the partially bonded unhybridized p orbital that develops, which develops over here, right? Which develops over here, suppose. So that is stabilized by resonance. Yeah, that is stabilized by resonance. Stabilized by resonance. So that is also one of the condition or one of the reason why we say both assertion and reason are true and reason is the correct explanation of the assertion. Okay. Now let's move on to the next question. High concentration of strong nucleophile reagent with secondary alkyl halide which do not have bulkyl substituents will follow SN2 mechanism. Yes. Basically, what happens, SN2 happens in the case of strong nucleophile. Why strong nucleophile? Because if the nucleophile is strong, suppose I am saying that this is R and this is R, this is H, because this is 2 degree na. So here we have leaving group and here we have nucleophile. If the nucleophile is strong na, then it can form bond with ease with this carbon. So before the breaking of carbon and leaving group bond, nucleophile attacks on this carbon, right? Nucleophile attacks on this carbon before the breaking of this carbon. So that's why yes, SN2 happens when we have more concentration of the nucleophile or we have a strong nucleophile. Question next. Statement 2. A secondary alkyl halide when treated with large excess of ethanol follows SN1 mechanism. Yes, if we have ethanol, so ethanol is what? CH3 CH2OH, right? So this is polar protic solvent. So polar protic solvent, why? Because hydrogen is bonded to more electronegative atom, so it favors acid one. Why? Because polar protic solvent solvates both cations and anions. It means it makes the anion bulkier. When it makes the anions and cations bulkier, so it means so many water molecules they attach themselves to the anion wala part. And if attach themselves to the anion part, then what happens? Less nucleophilicity of that anion. So if the anion is going to be less nucleophilic, then rate of SN2 decreases. Okay, so it means we can say both statement 1 and 2, they are true. So option A is going to be the correct answer. Okay, so we have discussed questions based on the GOC and reaction mechanism. Now we have simple type of question in this type 2, that is on the basis of classification of halogen derivatives. So let's do it. So question number 1 is examples of vinylic halide. So what is vinylic halide? So vinylic halide, it means halogen is bonded to sp2 carbon. sp2 carbon, right? So that is going to be vinylic halide. Okay, so we have to find out which one is allylic, or sorry, vinylic. So see, this carbon, right, this carbon is bonded to sp2 hybrid carbon, so this is going to be allylic halide. Okay, this is going to be allylic halide. It means carbon which is bonded to functional group is bonded to sp2 hybrid carbon, so that is the condition for allylic. Okay, if you see this one again, carbon which is bonded to functional group is bonded to sp2 hybrid carbon, so that is again allylic halide, right? That is again allylic halide. If you see this one here, carbon bonded to, or we can say functional group which is halogen, right? Functional group is bonded to sp2 carbon, but that is from aromatic ring, right? Aromatic carbon, because this benzene ring is aromatic, so this is known as phenylic. This is known as phenylic. Okay, now last one. Here, functional group is bonded to sp2 hybrid carbon, right? Functional group is bonded to sp2 hybrid carbon. So this is going to be the vinylic halide. Vinylic halide. So option D is going to be the correct answer. Okay, option D is going to be correct answer. Even option C, that is a phenylic one, a phenylic position, or we can also call this as aryl halide. That is aryl halide. Clear? That's a simple classification based question. Now, let's do next question. Next question says, given below are two statements. One is labeled as assertion A and other labeled as reason R. So assertion A is CH2 double bond CH, CH2 Cl is an example of allylic halide. सही बात है. Carbon bonded to functional group. What is allylic halide? Carbon bonded to functional group is bonded to sp2 hybrid carbon. So carbon bonded to functional group is bonded to sp2 hybrid carbon. So A is true. So assertion A, it is true. Now let's check for the reason R. Allyl halides are the compounds in which halogen atom is attached to sp2 hybridized carbon atom. Allylic halides, right? Allylic halides are the compounds in which halogen atom is attached to sp2 hybrid carbon. No. Halogen atom is attached to sp3 hybridized carbon atom. Understood? So it means this statement is false. This statement is false. So basically what we can say, A is true but R is false. Option A is going to be the correct answer over here. Clear? Is it clear? Now let's do the next question. So next question is completely based on the physical property. So physical properties mein we are going to discuss questions which are related to boiling point, melting point, density and all. Right? So let's do it. So the question number 1 says the correct order of melting point of dichlorobenzene. Dichlorobenzene. So see, dichlorobenzene. So this is the para dichlorobenzene. This is the meta and this is ortho. Right, this is para dichlorobenzene, this is meta dichlorobenzene, and this is going to be the ortho dichlorobenzene. ठीक है, ortho dichlorobenzene. अब now we have to check the melting point. So we know that melting point is directly proportional to molar mass. Right? If you see, molar mass is same because same ही है, same number of carbon atom, same number of hydrogen atom, same number of chlorine atom, all are same. So it means we have to check the symmetry. So in para 1 symmetry is more, right? In para 1 symmetry is more. Symmetry is more. So para melting point of para is going to be more. अब now out of meta and ortho, how to decide? So now we have to check the dipole moment. Now we have to check the dipole moment. So if we see the ortho one, so let's extrapolate this. So here theta is equal to 60 degree. Right, theta is equal to 60 degree. How? See, we have benzene. Let's divide this. So total how many angle? 1, 2, 3, 4, 5, 6. So 360 divided by 6, that is equal to 60 degree. So here theta is equal to 60 degree. But if I extrapolate this, so here theta is equal to 120 degree. So we know that when theta increases, so cos theta value decreases and dipole moment decreases. What is dipole moment? It is under root mu1 square plus mu2 square plus 2 mu1 mu2 cos theta. Clear? So it means what we can say that dipole moment of ortho is more than the dipole moment of meta. So melting point order is going to be para, then ortho, and then meta. Now we have to check the correct option. So para, ortho and meta. Understood? So fourth is going to be the correct answer. Right? Fourth option is going to be the correct answer. That's it. Clear? Now let's check this thing. So identify the correct order of the given property of the following compounds. So how to find out? So see, we have the options like ABE, ACD, ACE, BCD and all. Okay, so just check the first one. So boiling point. So boiling point is directly proportional to molar mass. So first we have to check for the molar mass. So if you see that here number of carbon atoms are more, 4 carbon. Here we have 3 carbon and here we have 2 carbon. 2 carbon, 3 carbon, 4 carbon. So here molar mass is more, right? Molar mass more. So we can say boiling point is more. So it means this is going to be the correct one. This is true. This is correct. Okay. Now we have to check for B. So for B1, how to check? So beta see. 2 carbon, 2 carbon, 2 carbon. Right? 2 carbon, 2 carbon, 2 carbon. Now what we need to check over here, density is equal to mass upon volume. Right? Density is equal to mass upon volume. So if bromine, or we can say chlorine, bromine and iodine. So on moving down the group, mass increases. On moving down the group, mass increases, volume also increases. Right? Volume also increases. So if we go by the mass, if we just want to go by the mass, so what happens? Iodine more than bromine than chlorine, right? It should be the order. Now here we have iodine, chlorine and bromine. So this is going to be the incorrect order. So this statement is incorrect. But this part is incorrect. It means there is no need to check for the वॉल्यूम एंड ऑल, मतलब मास से भी यू कैन चेक इजीली. Otherwise, we know that iodine का size is going to be more in comparison to bromine and chlorine, so the density is going to be little less. ठीक है? Is it clear? Now, next, boiling point. If we want to check for the boiling point, so here 1 2 carbon, 1 2 carbon, and here we can say 1 2 carbon, right? 1 2 carbon. So the point is that boiling point, we know that boiling point is directly proportional to molar mass. So obviously in C1 molar mass is more. So this is going to be the correct one, right? This is going to be the correct one. So we have A and C correct. So if we have A and C correct, so A and C correct. So we can have option number B and option number C. But up now we have to check one, D, either D or E. So let's check E, because boiling pointer we can easily relate this. So E, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So here mass is same. Mass same. So it means we have to find out boiling point is directly proportional to surface area and inversely proportional to branching. Inversely proportional to branching, it means this is going to be the correct. This is going to be the correct. And on the basis of that, we can say that the option C is going to be the correct answer. But let's check for the density wala. So see, 1 2 3, 1 2 3 carbons, 1 2 3. So carbon atom same. So iodine and bromine, then bromine, then bromine and chlorine. So obviously if we go by the mass, so more mass, more density, more volume, less density. So that is going to be the incorrect one. Or we can say ki this is completely experimental, so you have to relate with boiling point and melting point more, right? So you can use the elimination method in order to solve this question. Clear? That's it. Now let's do some question which is completely based on the preparation, right? So question says maximum number of isomeric monochloro derivatives which can be obtained from 2, 2, 5, 5 tetramethylhexane by chlorination is tetramethylhexane. So hexane is 1 2 3 4 5 6. 2 2 1 2 3 4 5 5 CH3 CH3 CH3. ठीक है, here we have CH2, here we have CH2. ठीक है, so the point is maximum number of isomeric monochloro derivatives. So monochloro derivatives means we have to do free radical reaction, right? We have to do free radical reaction, and that happens in the presence of UV light, right or wrong? It means we have to generate free radical. So if you look this all yellow highlighted, right? So yellow may on yellow highlighted carbons, if we remove hydrogen, we get 1 degree radical, right? 1 degree radical. Then we have this one CH2 and CH2. Ab now on green highlighted carbon we get 2 degree radical, है ना? 2 degree carbon radical. So now let's join. So on yellow पे let's join chlorine. So we get CH2, Cl, C, CH3, CH3, 2, 3, 4, and then C, CH3, CH3, and then CH3. You get the same. मतलब you can attach chlorine with this, you get the same. You can attach chlorine with this, you get the same compound. You get same compound with this, you get same compound with this, you can get same compound with this. So from yellow one you get this one, and from green one, so एक minute, let me highlight this green one with the yellow. ठीक है, so from yellow one we get this one, and from green one, so we get CH3, CH3, then CH3, any green. So I'm attaching Cl with this one, then CH2, CH3, CH3, and CH3, right? Ab now, so from green one we get this one. ठीक है बेटे? But if you see this बच्चे, so this is the chiral carbon. This is the chiral carbon. So if this is the chiral carbon, so it means we are going to have two isomers na, R and S. So total number of isomeric products, one for this one, 2 and 3. So total 3. Total 3. Okay. So answer is going to be 3. Clear? That's it. Now let's do some questions based on the chemical properties of haloalkanes and haloarenes. So let's do question number 1. Question says the major product P formed in the given reaction is. So see, what do we have? If you see the substrate, so we have here Cl and here we have anhydrous AlCl3. Okay, and if you see the option, it means ring formation happens. So how to think? If ring formation happens, it means carbocation is formed, right? Carbocation is formed. And what is the role of AlCl3, anhydrous AlCl3? So it has empty orbital, bete. Okay, it has empty orbital. This is Lewis acid. It is Lewis acid. Why? Because it has only 6 electrons. So what happens? It takes Cl minus. So Cl minus, it gives electron to the empty p orbital of the aluminium and we get AlCl4 minus. Okay, we get AlCl4 minus. So from this, what do we have? We have this OCH3, then we write NO2, then we write 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Then this, and here we have Cl na. So Cl, it is removed. So if Cl is removed, right, or we get Cl minus plus AlCl3, it forms AlCl4 minus. Okay. So we get bete OCH3 NO2 1, 2, 3, 4. Right. So here we get positive charge. Right. So this is 2-degree carbocation. So, but we cannot do any kind of shift hydrogen, methyl and all. It is not possible because we get only 2-degree carbocation then. Okay, if we form carbocation over here, again we get 2-degree carbocation, right? So we cannot do any kind of shift. But what we can do ring expansion. Up now we have two situations. The point is, suppose this double bond, right? This double bond electrons, they attack on this carbocation. So if they attack on this carbocation, it means these two electrons, they come over here. So here we have negative charge. That's why we have the bond formation like this, right? We have the bond formation like this. And then new positive charge, it is developed on this carbon. So if I draw this structure, so we get this one. OCH3 NO2, here we write positive charge. Now see, 1 number, 2 number, 3 number, 4 number, 5 number, and here we say 6 number. So we get 6-membered ring. Okay. So this is 1 number, 2 number, 3 number, 4 number, 5 number. Now 5 number is bonded to methyl group. Okay, bete? 5 number is bonded to methyl group. Now this positive charge is nearer to the electron releasing group. Okay. A point is that you can also form bond from this carbon. So if you form bond with this carbon, right, so you get positive charge over here. If you do this now, if you do this green one, then you get positive charge over here. ठीक है बेटे, positive charge over here, which is nearer to electron withdrawing group, beta electron withdrawing group. So it destabilize, right? So it is less stable. So this is not going to happen. Ab now we have AlCl4 minus. So what will it do? It will abstract proton and electron of this bond shifts over here. So when this happens, we get OCH3, NO2 and this. ठीक है. So this is going to be the answer. Clear? And with that we get AlCl3 and HCl. So what is going to be the answer? What is going to be the answer? So we get 1. Option 1 is going to be the correct answer. Clear? That's it. Okay. Now moving on to the next question. We have 2-methyl propyl. 2-methyl propyl bromide, right? 2-methyl propyl bromide. So basically 1, 2, 3. 2-methyl propyl bromide. Okay. So we have this one. CH3, CH, CH2. Reacts with C2H5O minus. Right? C2H5O minus. And gives A. And gives A. ठीक है बेटे? Gives A. Whereas on reaction with C2H5 it gives B. Whereas if we have this one CH, CH3, CH2Br on reaction with ethanol CH3, CH2OH it gives B. Right. So the mechanism followed in this reaction and the products A and B respectively are. So up C you need to know what is the role of this region. So see, if we have alcohol and heat, if we have NaNH2 and heat, if we have alcoholic KOH or alcoholic base and heat, right? If we have this one or if we have alcohol plus base and heating is there, right? So it means we have to do elimination reaction. We have to do elimination reaction. Now the point is how do we find out whether we will do elimination reaction or we will do substitution reaction, right? We will do elimination reaction or we will do substitution reaction. So the point is that if you see here what happens, this O minus, this is delta negative and this is delta positive. So this O minus, this attacks on this one and Br removes, we can remove Br. Okay. So if we do this, so we have CH3, CH, CH3 and this is CH2O C2H5, right? O C2H5. If you see this reaction is similar to Williamson synthesis in which we prepare ether, right? So we have this RO minus Na plus and if we have this R dash X, so we will do SN2 reaction generally and we get what? RO R dash. Okay? So we get this as the compound because heating is not there, so we cannot do the elimination reaction. Okay? We cannot do the elimination reaction. So answer is going to be SN2 and we get isobutyl ether. We get isobutyl ether. Understood? Clear? We get isobutyl ether. So ठीक है, let's do this. So we have this isobutyl group and this is ethyl ether. Now next part is we have alcohol. Now what to do over here? So see, the point is it cannot attack easily, right? So here what we are going to do, let's remove Br. So if I remove Br, so we get CH3, CH, CH3 and then CH2 positive. Okay. Up now what we can do? We can do 1,2 hydride shift. 1,2 hydride shift rearrangement. So if I do so, so we get CH3, C positive. Now CH3, now CH3. अच्छा अब देखो this is there is one more thing ना, देखो यहाँ पे this is polar protic solvent kind है ना, polar protic solvent. So if it is similar to polar protic solvent, it means hydrogen is attached to more electronegative atoms, so it tries to do SN1 reaction. So here I am trying to do SN1 reaction, but here we get 1 degree carbocation which is unstable, which is not that much stable. So I am doing rearrangement in order to make 1 degree carbocation 3 degree carbocation. Okay, so अब now we have 3 degree carbocation. Now next step what happened? We have CH3, C, CH3. This is positive CH3. Now CH3, CH2 and OH. It becomes electrophilic, na? Now it becomes electrophilic. It becomes electrophilic. Now oxygen can easily attack on this. So when oxygen attacks, so we get CH3, CCH3, CCH3, and here we write OH positive and then CH2, CH3. Up that Br minus, right? That Br minus, it takes this hydrogen and electron of this bond shifts to oxygen. So we get CH3, CCH3 and then CH3 and this OCH2, CH3. ठीक है? So we get third butyl ethyl ether. We get third butyl ethyl ether. So answer A is going to be the, or option A is going to be the correct answer. Clear? Now, moving on to the next question. We have one bromopropane. We have one bromopropane. It means CH3, CH2, CH2Br. Now it is reacted with reagent. So this is reagent based question. It's what? Reagent based question. So you should know the role of reagent, right? So if we use alcoholic KOH, alcoholic KOH, we have to do elimination. So if I do elimination, so product is going to be alkene. Okay, bete. So A can be matched with third. Now just look the option. We have only one option. है ना? So this is going to be the answer. But yes, let's understand. Let's understand the next part. See, bete. See, we have KCN alcoholic. KCN. So we have KCN na. So K plus and CN minus bache. So we get nitrile. Nitrile because if I have RX, so CN minus attacks over here and we get RCN. Clear? Plus KX. Okay. So B can be matched with first. Now we have AgNO2. If we have AgNO2, so AgNO2, it is like this. So here we have nitrogen, lone pair on nitrogen, even we have lone pair on oxygen also. Nitrogen is less electronegative, so it is going to act as nucleophile. So it attacks on this X leaves. So we get RNO2 plus AgX. ठीक है? So we get nitroalkane. We get nitroalkane. So C can be matched with fourth, B can be matched with first, and C can be matched with fourth. ठीक है? Now last option D. We have CH3COAG, right? We have CH3 C double bond O OAG, and we have what? RX, na? So what you are going to just remove AGX. So we get CH3 C double bond O OR. So we get ester. Clear? We get ester. That's it. So answer is going to be option number 1. Okay. Now let's do next question. The major product formed in the Friedel-Crafts acylation. So in acylation, reagent is RC double bond OCl and anhydrous AlCl3. So here chlorobenzene ka you have to do Friedel-Crafts acylation, and if you see option, so it means we have CH3 C double bond Cl plus anhydrous AlCl3. So first Cl minus leaves and we have carbocation formation like this plus AlCl4 minus, and the role of this is going to abstract proton abstraction in order to maintain aromaticity, So let's do this. So we have chlorobenzene. So chlorobenzene, although inductive effect dominates over here, inductive effect, so it shows minus I. It's an electron withdrawing group, but less electron withdrawing effect because inductive effect, है ना? Less electron withdrawing effect, due to which it is ortho and para directing. Okay. So ortho and para directing means what happens if we have Cl over here, so we get C double bond O CH3 over here. This is electrophilic aromatic substitution. So para is going to be the major product. So answer is going to be option number 4. Clear? Answer is going to be option number 4. Now moving on to the next question. Next question is this. Okay, so we have cyclobutane. We have cyclobutane. Here we have Cl and here we have Br. And this is Na in the presence of diethyl ether. So it means dry ether. This reaction is same as Wood's reaction, है ना? Wood's reaction. So what happens in Wood's reaction? If we have Rx, Na, Na plus Xr, right? So just remove NaX, NaX and join R and R. Join R and R. So on the basis of that, we have here two halogens. One is chlorine, another one is bromine. Right? We know that bromine is a good leaving group. Good leaving group. Then Cl. So what happens? Br leaves, right? Br leaves in comparison to Cl. So after this, Cl and this Br, if I write 2 and here we write Na and the dry ether, so we get this compound. Let's join from here. So here we write Cl and here we write Cl. Okay, so this is going to be first compound. A compound is this. Okay, bete. Now, then we have to find out COF2, right? COF2. So COF2, this is what? Swartz reaction. So by Swartz reaction, if we have COF2, right? H, or we can say, we can even have Hg2F2, right? So that is going to be the Swartz reaction. So in place of chlorine, I am going to put fluorine. We get fluoro, basically alkyl fluoride we get from the Swartz one. So we get this one as the answer. Okay, so that is C. Now we are moving to B. B. So what is the Mg dry ether again? So if we have Mg dry ether, we are going to form Grignard reagent. No, Mg dry ether, Grignard reagent. So here we write MgCl. Here also we write MgCl. Now we have D2O. D2O. So D2O is similar to water, H2O, but molar mass is 2. So it means we have to do hydrolysis. What? Hydrolysis. So we have to break this bond. Metal carbon bond. So obviously this is delta positive, this is delta negative. So here carbon के साथ I am going to attach OH, not OH. Here carbon के साथ I am going to attach H and H, or here we write D, not H, we write D, and here we write OD. Similarly, with this carbon we attach D, and with magnesium we attach OD. So B is going to be this one, D plus 2 molecules of MgCl and OD. Clear? So that is B. So we have to find out B and C, bete. So B and C. So what is B and C? So B is going to be DD and C is going to be FF. So option B is going to be the correct answer. Okay? Option B is going to be the correct answer. Clear? Now moving on to the next question. Identify the major product in the following reaction. So if you see the reagent, so reagent is alcohol plus base, right? Alcohol plus base. So it should do elimination reaction, right or wrong? It should do elimination reaction. But the point is that heating should be given. Heating is not given, but just look the options. Look the options. So in the options we have alkene, right? So it means we have to do elimination reaction. So see, if we see this one, so this is 3-degree alkyl halide. Okay, this is 3-degree alkyl halide. So what happens? We are going to perform E1 reaction, right? E1 elimination reaction. So what we are going to do? First remove Br. This is CH3. So on removing Br, we have positive charge on this carbon, right? Positive charge on this carbon. Now this is we have here we have hydrogen, so we can say beta 1 hydrogen. Here we have hydrogen, that is also similar to beta 1 hydrogen, right? Beta 1 or ये beta 2 मान लो, and here we have hydrogen, so इसको I can say beta 3 hydrogen, right? So the point is beta 1 and beta 2 same, right? Beta 1 and beta 2 same, so if you remove any beta 1 or beta 2 hydrogen, you get the same product. So OH minus, it abstracts this hydrogen and electron of this bond shifts over here, so we get this, right? If you remove beta 2, the OH minus subtract this hydrogen and electron of this bond shifts over here. So on removing beta 1, we get this one. On removing beta 2, we get this one. See, this one. Same product, na? We get same product, right? And now on removing beta 3 hydrogen, we get this product, double bond CH2, right? So that's a Sedgwick product. That's a Sedgwick product. Sedgwick product, more alkylated product. So check, more alkylated product. So see, 1, 2 and 3 and only one hydrogen. So that is going to be the answer. Clear? So now look. So what is the answer? Option number B is going to be the correct answer. Okay, we cannot have this, we cannot have this, we cannot have this. Okay, now let's do next question. The next question says CH3, CH2, CH2Br, NaOH is C2H5OH, right? So again same thing, right? NaOH है, so we can say we can have C2H5O minus, right? We can have a C2H5O minus, Na plus and water. The point is that we have alkyl halide. It can also form ether, na? It can also form ether. But if you see this one, the product A on reaction with H2OH plus, which is called acidic hydration, right? We get product B, and this is diborane. Diborane yani B2H6. So this is hydroboration oxidation reaction. So it means product A should be alkene. And here we get alcohol. Product B is going to be alcohol. Even product C is also alcohol. But here we have to form alcohol by Markovnikov addition. Markovnikov addition. And here we have to form alcohol by anti-Markovnikov addition. Understood? So heating should be there in this question, right? Heating should be given, but if it is not given, then we have to check other factors which can decide how to proceed the reaction. Okay, so here we are going to form alkene. So let's form alkene. So we have CH3, CH2, CH2Br. Okay, so this is alpha carbon, this is beta carbon. So let me write one hydrogen like this. Now what happens? OH minus, it takes this hydrogen, electron of this bond shifts over here and Br leaves, so we get CH3 CH double bond CH2. As this is 1 degree alkyl halide, so mechanism is E2 elimination. In one step we are going to do. Okay, up now we have H2OH plus, that's a Markovnikov addition. So Markovnikov addition means negative adenine goes to that carbon which has less number of hydrogen across the double bond, right? If OH minus goes to this carbon, so that's Markovnikov, and if OH minus goes to that carbon, so that is anti-Markovnikov, right? So H2OH plus, so we can say CH3 CHOH, and here we write CH3. This is what? 2-propanol, and I guess this is a product B. This is product B, bete. So this is product B. Now in this B2H6 hydroboration oxidation reaction, so we get CH3 CH2 CH2OH, which is 1-propanol, and that is going to be product A. Okay. Now we have not product A, product C, sorry, product C. This is product C because this is product A, है ना? Alkene is the product A. Now we have to find product B and C. So B is what? 2-propanol and C is what? 1-propanol. So option D is going to be the correct answer. Okay, is it clear? Now let's do next question. Find out the major product formed from the following reaction, and Me is CH3, right? It is methyl. So how do we find out the product? So see, we have Me2NH. So it is going to be a nucleophile. We have Br minus, it is going to be the leaving group. But we have one situation over here. Okay, we have one situation over here कि double bond is in conjugation, right? Double bond, मतलब it's not in conjugation. The point is that if we have double bond like this now, so what happens over here? Just try to understand. We have double bond over here, and this is Br and this is Br. So in general, if we have Me2NH, okay. So generally Me2NH, so NH should attack over here and Br leaves, right? This should happen. This should happen. But the point is that we are not going to write, or we are not going to attack in this way. What happens? This nitrogen lone pair attacks on this double bond, on this carbon. Then this bond shifts over here and Br leaves. Why? Because delocalization. So delocalization of electron means stability, right? So with resonance, we have more resonating structures, it means more stability. So in that way, if we do some kind of delocalization, then it provides stability. Now here what happens? Double bond and leaving group are in conjugation. We can have resonance, right? Are in conjugation, or we can say that ki bhai it can easily leave, matlab Br leaves, right? By the movement of double bond. So we are going to attack on double bond. If this is not the situation, then we have to do A. But here we have to do B attack because double bond is there, and due to the movement of the double bond, Br can leave. So what happens? So what do we have? We are going to write this product bit. Here we write NH positive, and here we write Me and Me, and this is going to be Br. Now Br minus, it abstracts proton and electron of this bond shifts to nitrogen. So we have this situation, Br and Me and Me. And now what happens? Nitrogen, it has lone pair again. We know that intramolecular attack is faster than intermolecular attack. Intramolecular attack is faster than intermolecular attack. So what happens here? Nitrogen lone pair attacks on this carbon because this is delta positive, delta negative, and Br leaves. ठीक है. अब now we do not have this situation कि double bond and leaving group है, they are in conjugation, या by the movement of double bond we can remove leaving group. So we do not have this kind of situation, right? So what do we say? कि we have this, and here we have N, right? Me and Me. So here nitrogen, it has positive charge, बच्चे, it has positive charge. Next, NH Me2. ठीक है. अच्छा, if we have one more double bond ना, तो we can also expand the ring. But if you see the option, we have only 5-membered ring. So देखते हैं, let's see. So NH is going to attack on this carbon, बच्चे. It is going to attack on this carbon and this bond dissociates. So we get Me2, and here also we get Me2. So this is going to be the answer. Okay, so let's find out the correct answer. So option A is going to be the correct answer. Okay ji, option A is going to be the correct answer. Okay, now let's do next question. We have this CH2Br NaOH, alcoholic KOH, reagent based question, reagent based question. So what happened? Alcoholic NaOH, so it will do elimination. So let's do elimination. So first, what we are going to do, bete? Ek minute. What we are going to do? Here we have this Br C, and this is CH2Br. Here we have hydrogen, and here we have hydrogen. So NaOH, alcoholic NaOH है, so it is going to be a base. If we have aqueous NaOH, then it is going to act as nucleophile. ठीक है, alcoholic NaOH base, because bigger nucleophile, they are going to act as base. And what is base? Which abstracts proton. So what happens? OH minus takes this hydrogen, electron of this bond shifts over here and Br leaves. So we have the formation of alkene, and we know that from elimination reaction we form alkene. So we get CH double bond CH2. ठीक है? We get CH double bond CH2. ठीक है? So this is B. Okay. Now C. If we have B is this. This is what Br. Then CH double bond CH2. Now we have HBr. So peroxide is not given, sunlight is not given. It means we have to do Marconic of attack. So Marconic of attack means hydrogen goes to that carbon which has less number of hydrogen across the double bond. So it means our answer is going to be this CHBr, and this is going to be CH2. Right or wrong? ठीक है. So let's write down the correct answer. So the first में we have the double bond and second में this. So option A. ठीक है, option A. But we have to find out how are A and C related. So see, A पे on this carbon we have bromine, first number carbon, and in B on second carbon we have bromine. So they are positional isomers. They are what? Positional isomers. Understood? So option A is going to be the correct answer, because position of functional group is different. Clear? Now let's do the next question. So next question says, bhai, haloalkanes react with KCN to form alkyl cyanides as main product and AgCN form isocyanide as a main product. सही बात है. KCN. So this is ionic compound. So it dissociates into its ions. So we have C triple bond, and so we have negative charge on carbon. How? Because nitrogen has 5 electrons now. So Y valence electron. So 1, 2, 3, 4. Right? 1, 2, 3, 4, or this is 5. Now carbon के we have 1, 2, 3 और एक 4, or due to this negative charge we have 1 extra electron. So in that way, if you see, both have 8 electrons. So it means carbon has negative charge. So if we have Rx, so Cn minus attack, na, carbon attacks on R and X leaves, because alkyl group, in the alkyl group we have positive charge. Carbon is less electronegative than halogen. So we get bete RCN plus X minus leaves. Now X minus forms bond with K plus to form KX. ठीक है, very good. Now we have AgCN situation. If we have AgCN situation, so AgCN is covalent. So now nitrogen lone pair hai. We have lone pair on nitrogen. So nitrogen is going to act as nucleophile. Nitrogen is going to be the donor atom. So if we have Rx, so nitrogen is going to attack on R and X leaves, and we have RNC situation and then AgX. ठीक है बेटे, clear? So this is going to happen. So this statement is true. KCN and AgCN are both ionic compounds. No. AgCN is covalent. AgCN is covalent. So this is going to be the false. So assertion is true and reason is false. Assertion is true and reason is false. So option A is going to be the correct answer. Understood or not? Is it clear? Okay. Now let's do next question. Identify A and B in the following reaction sequence. So we have Br, है ना? We have Br. So Br है, it shows minus I effect. So but it is ortho and para directing, because weak effect है. Minus I, it's a temporary attraction of electrons, right? So it's a weak, so ortho and para directing. So if we have concentrated HNO3, so usually what we are going to write, bete ortho NO2, or we can say para NO2. ठीक है. अब now if I use NaOH or HCl, so that's a Dawes process. Dawes process में first what happened? We get O Br removed, or we can say ONA hoga and NO2. And then in the presence of HCl, we can say we get OH or NO2. है ना बेटे? Let me rewrite this. We get OH and NO2. So we should be getting this one. Now, this is the ideal situation. But now see the options. We do not have this product. No, we do not have this product. What do we assume here? What do we assume? Ki here concentrated HNO3, but that is in excess. If concentrated HNO3 is in the excess, so we have Br, here concentrated HNO3, so we get Br, here we write NO2, here we write NO2, and here we write NO2. ठीक है? Next, if we are going to treat this with NaOH and HCl, NaOH and HCl, so what happened? Nucleophilic substitution reaction. So we get OH, NO2, and NO2. ठीक है? Clear? That's it. So we have to assume this thing. If we have concentrated HNO3 is in excess. Otherwise, we cannot have the product. We cannot have the answer. So on the basis of that, what do we have? Option C is going to be the correct answer. Clear? Okay, G. Now moving on to the next question. The final product A formed in the following multi-step reaction. So that they are based on reaction mechanism. Okay, you should know the property, or you should have the idea about the function of regions. Okay, so first we have Br. Br, we have Mg. Mg in presence of dry ether. So we are going to form Grignard region. So when we form Grignard region, so MgBr. So we have this situation. Okay, we have this situation. Then we have CO2. CO2 is this. Now if we have Grignard region, so it is polar because delta positive, delta negative. Here we write delta positive, delta negative. So it shows nucleophilic addition reaction. So this carbon attacks on this carbon. Electron of this bond shifts to oxygen, and then oxygen forms bond with Mg. Okay, so negative goes to positive. So what happens? We write C double bond O and then O MgBr. Then we have H plus. So hydrolysis करना है. So on hydrolysis, we are going to break oxygen and metal bond because more electronegativity difference. So magnesium delta positive, oxygen delta negative. So here we write H, and with Mg we write OH. So we have C double bond O OH plus MgBr OH. Clear? Now next reaction. Now we have the reaction of carboxylic acid. Now this is the reaction of carboxylic acid, but we can do it easily. NH3. If we react this with NH3, so this is acid and this is base. So we are going to do acid-base reaction. So acid means proton donor and base means proton acceptor. Proton acceptor. So we write C double bond O NH4 positive. Right. Now on heating we are going to remove water. So on heating water, so hydrogen is removed from this and oxygen is removed from here. So we get this one, C double bond O NH2. So this is amide. This is what? Amide. Clear? This is amide. Now we have Br2NaOH. Br2NaOH. So this is C double bond O NH2. And then we have Br2OH minus. This is what? Hoffman bromamide degradation. Hoffman bromamide degradation. So this is used to form 1 degree amine. Used to form, कर सकते हो आप ये, मतलब what we are going to do over here कि just remove CO, यही करना है. So we have NH2, right? We have NH2. Clear? So on the basis of that, we have option number C. So here we have used the reaction of amines. right? Hoffman bromamide degradation, that is the reaction of amine. So this is the beauty of organic chemistry. We can, matlab, there are lots of reactions that you need to memorize in order to get the correct answer. If you know, then you can easily do this. Okay, and now this is also reagent based question. That is also reagent based question. So reagent based question. See, if we have CH3, CH2, hold for CH3 and hydroCl3, whenever you see na, it means you have to form isomers. This is the region which forms isomers, but you cannot form this isomer. Cannot form this type of isomer, which includes this group. Which includes this group, you cannot form this isomer. So we have this hexane, so it means you have to form hexane ka isomer. So hexane ka isomer. Let's form chain isomer. Now 1, 2, 1, 2, 3, 4, 5, and just put one carbon in branching. So this is the isomer. You can also form 1, 2, 3, 4, 5. You can put carbon over here. It's just now you have to check from the option. So answer is going to be this one. ठीक है? Is it clear? That's it. Now do this question. Let's do this question. So what happens in this question? We have this compound, okay, and we have this third butyl lithium. So what happens here? What do we have? We have Li over here, and here we write OLi. Right, so this is similar to, we can say, Grignard region type, because this is CH3 and CH3 and this is Li. So this is going to be a good base, right? This is going to be a good base. So delta positive and delta negative. So here we have acidic hydrogen, right? We have acidic hydrogen. So first work of जैसे Grignard region का है, ऐसी same with this one. So first work is that to abstract hydrogen. So here carbon is going to abstract this hydrogen. This bond comes over here and oxygen forms bond with lithium. Right. This is going to happen and this is how we get OLi. ठीक है. अब now here we have Br. So we know that now if we have Rx plus Mg, so we get RMgx. So similarly here also we get Li. Is it clear? We get Li. So let's see the further reaction. So if we have Li over here and OLi over here, and now we have CO2, C double bond O, CO2. So this is delta negative, this is delta positive. So we are going to do nucleophilic addition because now we do not have any acid. So this is going to attack over here, this comes over here and oxygen forms bond with lithium. So in this situation we have C double bond O and this is OLi, and here we have OLi. Next, we have H2O positive. H2O positive means we have to do hydrolysis. And when we do hydrolysis, so we have to break this bond. We have not this bond, we have to take oxygen and metal bond. So here we write lithium delta positive, oxygen delta negative. So here we write H, here we write OH. Similar with this one, here we write H, here we write OH. So we get COOH and OH. Okay. So question says what is A? So A is going to be B. So this is similar to Grignard region wala, right? That's it. Now, so the last question for today's class is this. So we have to find out A and we get 4-bromophenyl acetic acid. 4-bromophenyl acetic acid. So we have this one. 4-bromophenyl acetic acid, CH2COH. We know that on hydrolysis of cyanide, we get carboxylic acid. How? See, you have to dissociate 3 bonds. So delta negative, delta positive. Here you write OH, here you write OH, here you write OH. H, H, H. Because you are dissociating 3 bonds. So you get NH3 and then C double bond O, OH. Because now 2 OH are unstable on 1 carbon. So we are going to remove water. Okay? So we get this one. Up on hydrolysis na, of this, we get carboxylic acid. So here we write this is Br and this must be CH2Cl. We have chlorination and heat, right? So it means we can say before that we should be having CH2Cl, right? Before that we should be having CH2Cl. And if we have CH to Cl, before that we have CH to Cl, तो Cl2 किया था ना इसे heat, so it means it must be CH3, because अगर heating है तो it means we have to do free radical ना, and free radical is possible on alkane, so we should be having any alkane group. ठीक है. So if we see correct answer, so which is going to be the correct answer बच्चे? This one. ठीक है. Option C is going to be the correct answer. That's it. So all done. We have discussed all questions. Okay, students, we have completed next chapter of organic chemistry. I have discussed enough questions which provides you clarity, which can give you the enough clarity about the concepts and all. It's just you have to do other PYQs on your own. Just keep doing, focus on doing. If you do 10 to 20 questions daily, right, of organic chemistry, you can get a good percentile in your upcoming JEE Mains, right? But you have to do organic chemistry questions daily. In the next video, I will be taking alcohols, phenols and ethers. So please go through your notes, just revise alcohol, phenols and ethers completely. Most important reactions of ethers like just a Williamson synthesis. We have Williamson synthesis, so there are certain reaction of ethers, right? And we have similar kind of mechanism in all reactions of ethers. So just go through that part. Alcohols reactions are similar to the hydrocarbons reactions and haloalkanes, haloarenes reactions. If we talk about phenols, so phenols reaction, they are similar to the aromatic hydrocarbons reaction, but the more similar, we have different reactions. But the point is that idea is that just go through all the reactions, right, before watching the next video. I hope you like the video, and if you like the video, then drop a comment, right? Hit a like button, and you can also join the PracBee Revision Program. Even you can join the PracBee 1-to-1 session in order to clear your doubts, right? In order to clear your doubts, you can join PracBee 1-to-1 session, and everything which is related to program and other things which are related to assignment, solved assignment, unsolved assignment, that is all in the description box. You can find everything in the description box. Okay, that's it from my side. Bye, take care, see you in the next video.